Let's move on. Question 3. You are given that ABCD is a rectangle. The area of the rectangle is 80. And then you have two triangles that are removed. The important thing is they tell you BP is equal to QB. So this is equal to this, and it's also equal to BR, and it's also equal to SD. And they're all 4 cm. Then they tell you that AD is X. So this entire thing is X. Find an expression in terms of X for AQ. Take note, area of the entire rectangle is 80 cm squared. And area equals to length times breadth. So the first thing you can find is the length AB. So AB is your area divided by your breadth. Okay? And therefore, AQ is just AB minus 4. You can just leave it as such. Take note that you are supposed to write the bracket. This one from primary school days, you already learned. If there's a unit to addition or subtraction in algebra, you need to put the bracket. Some of you will simplify this into a single fraction. You want to simplify the single fraction, you can go ahead and do that. So you will get 80 minus 4x over x. Okay, if you find that to be more convenient, up to you. Show that the shaded area is given by y equals to 320 over x plus 4x minus 60. So actually, this is a quadratic question. It's your quadratic word problem kind of question. Just that instead of giving a direct quadratic, they give it in terms of an algebraic fraction. But fundamentally, nothing much changes. So to find your shaded area, you know that your shaded area is the area of the whole rectangle minus away the two triangles. You have already found the length of AQ in part A. So we know that AQ is 80 over x minus 4. And obviously this length will be equal to this length based on the information given to you. You know that AP is x minus 4, and therefore RC will also be x minus 4. So you can find the area of triangle APQ. Okay, so first things first, the length AP is just x minus 4 because AD is x. And therefore, area of triangle AQP equals to area of triangle RSC equals to half times base times height. Okay, and this is maybe why some of you would have preferred to leave the answer as a singular fraction because you think it's easier to multiply. But either way, just multiply this out. So this times this times this. Okay, if you are sharp, you will realize that the half and the ATR x minus 4 can factorize out a 2, in fact factorize out a 4 to cancel away the half. Which is what I'm going to do to simplify it even further. Okay, it's not necessary to go through this step, but I've simplified it further just so that it's easier to multiply. So instead of multiplying at this stage, I multiply at this stage. So rainbow you will get 2 times x times 20 over x will give you 20. X times -1 will give you negative x. Then -4 times 20 over x will give you negative 80 over x. And -4 times 1 will give you +4. Okay, from here you can simplify and then expand, multiply out the 2. Or you can don't multiply out the 2 and leave it as it is, up to you. So you have 20 plus 4, so you have 24 minus x minus 80 over x. That is what you should have. Okay. So we find that this is the area of one of those right-angled triangles. And therefore, the area of the shaded area will be equal to your entire rectangle, which is 80, minus away 2 times such a triangle, because there are 2 such triangles. So remember to multiply by 2. So from here, you expand and simplify. So 2 times 2 is 4. So 4 times 24 is 96. So you will get 80 minus 96 plus 4x minus 4 times 80 is 320. But it's not minus, it will be plus, because minus minus to give you plus. So be careful with your sign. And therefore, this will simplify down to the 320 over x plus 4x minus 16 bracket full. Okay. So it's just quadratic expansion in this case, nothing complicated. Okay. Next, let's look at part C. They ask you to complete the table of values for this, and then ask you to draw out the graph. So what is missing? X equals to 18 has a missing y value. So you need to fill in the y value. So you sub in x equals to 18, your y value will be 320 over 18 plus 4 times 18 minus 16. You'll get 73.77 something, so it's 73.8. Make sure you remember to fill in the value. Then from there, you can plot and draw the graph. I'm just going to show you roughly what the graph looks like. So your graph will look something like this. Okay, I free-handed it on the iPad, so obviously it doesn't look very nice. Your graph should not be as wobbly as mine. Okay, you can very clearly tell that this was drawn freehand. I'm not saying you cannot draw freehand, but you better make sure your freehand graph looks a lot smoother than this. Okay, this graph for 3 marks, this graph will take a 1 mark deduction because not smooth. That is what will happen. Okay, but from the graph, we can use the graph to find the approximate values the greatest value of x when the shaded area is equal to 60. Now remember that, so this is where a lot of you forget. You look at the question like, what shaded area? You have forgotten that this equation represents your shaded area. So when they tell you the shaded area is a particular value, you just read off the graph and look for the shaded area being the particular value, which in this case is this value. Okay, that is how you find the area, the x value, or the greatest value of x when the shaded area is 60. You will notice that there are two values of x. You have x equal to 6.4, and you also have x equals to 12.7 when the area is 60. But the keyword in the question is greatest. So you cannot use 6.4 because clearly that is not the greater value. The greater value clearly is 12.7. All right. So there are actually two values of x here, 6.4 or 12.7, but they want the greatest. So you cannot accept 6.4, you have to use 12.7. So that's the logic. Explain how the graph shows that the shaded area cannot be equal to 50. So if I draw area equals to 50, which is this line, when I draw this line, which is the line y equals to 50, what does this show? You see that there is no intersection. Okay, so the graph does not intersect, or rather, you don't just tell me it does not intersect. The graph lies entirely above the line y equals to 50. Therefore, the shaded area must be more than 50 cm squared. Done. An alternative solution is to tell me that from the graph, minimum value of y equals to so from the graph, minimum value of y is approximately 55.5. Therefore, the shaded area must be more than 50. Okay? So these are the two explanations I think that can be accepted. Either tell me that it lies entirely above the line y equals to 50, or tell me that the minimum value of y is about 55.5, and therefore the shaded area must be more than 50. If you never tell me more than 50, you tell me more than or equal to 55.5 also can. So it's just a logical understanding question. By the way, please always make sure you label the equation. Now, some people will do weird things here and tell me, go and complete the square and show what the minimum value of the quadratic is. You will get 0, because they say explain how the graph shows, not go and complete the square. Anyway, this is not even a quadratic equation. How you go and complete the square? Okay.